Okay, I'm continuing with this intro notes and worksheet 1 page. So we're still here. I'm going to spend some time working on these motion maps. So go to this page. What I want you to do is read these 2 pages here. So read these pages. I'm going to pause the video. When you're done, you can unpause it. I'm going to just make sure we're on the same page. If you don't read this, it's completely useless. You have to read it first, and then I'll tell you what it is about. Hopefully you've read the page by now, so I'm just going to quickly explain everything. So motion map, there's this one axis that tells you position. You can see here x. Remember, x we use for our 2 position terms, right? Distance and displacement uses x. So wherever this dot is where an object is in terms of position. So a dot over here is further right, a dot over here is further left. Each dot is 1 second, so that's very important. Each dot is 1 second. If you see 9 dots, this object's been traveling for 9 seconds. If there's an arrow attached to that dot, that's how it's moving. This first section, we got a car moving to the right. We got arrows to the right, so I know it's moving towards that direction. And just so you know, these arrows, they represent velocity. Velocity is a vector, so that's why we're able to do this. We do the same scenario, except now it's 3 dots, and you can see these arrows are longer. I can surmise that this car is moving even faster. Another scenario here, instead of the arrows going to the right, now they're going to the left. I know my car is going to the left now. Now here's a more complicated motion map. Notice when you get more complicated, you should clarify where you start and where you end. Whether an object's up or down actually doesn't matter on the motion map. It's more where this dot lines up with this axis. So when you're drawing complicated motion maps, you're going to go higher or lower. So keep that in mind. The first second, my object is moving to the right at a pretty fast speed, and it does that for 3 seconds. Then it stops for 2. Notice these stop dots, there's no arrows attached to it. Then we move to the left at a slower velocity. We end and start at different spots. We start closer to 0. We end further than 0 than we started. We get this other scenario. Now, we're timing 2 cyclists, cyclist A and cyclist B. Cyclist B starts at the origin, the end of this graph here, while A is kind of further ahead. And we can see from the arrows, A's arrows are smaller than B's, so A is moving slower than B, who's moving faster. Well, if we give it enough time, you can assume that B at some point overtakes A, and we could see by the last second, B is starting ahead of where A is. So even though A had the head start, it wasn't moving fast enough to outspeed B. So now I'm going to draw it with a new graph, and we call this graph a position time graph. So position, because we've got position up here and time on the bottom. Whenever it's something versus something, the position versus time, position's on the vertical axis versus the horizontal axis, time. So we have this position time graph here, and basically I'm just mapping out, A versus B. We don't have any numbers here, but A starts ahead of B. I know it's not on the origin, and at some point B is further along. So that's nice. I can use this position time graph to it shows, I think, information a little easier than these motion maps. And what this is saying here is that, remember those y equals mx plus b equations you did in algebra? Well, instead of calling it y, we use whatever's on the vertical axis, which is x, which might be confusing. And instead of using x, we use whatever's on the horizontal axis, which is t. We can use this information to make equations for this, and I'll explain later v and x, how those play into it, but you can use that to describe these graphs, and that's what's really cool about this part of the unit. So, all right, I will stop this video here, and then I'll move on to worksheet 1, where we'll have actual practice with these concepts.